Let's try and connect these integration ideas with something familiar. At first, it's not going to make any sense because I'm just going to say, magically, these two things are connected. But the question came up yesterday, and so it's at least on one person's mind, and so we need to address that. So we need to introduce the concept of antiderivatives. Now, you already know how to do this because you know how to take derivatives. We just need to do that in reverse. Let's say f of x. Let's just do this example. Find the derivative. F of x is equal to x cubed. What's the derivative of f of x? If f of x is x cubed?
3x squared.
F prime of x is 3x squared. Nx to the n minus 1. Multiply the exponent by the exponent, subtract 1 from the exponent. So we need to learn to play this game in reverse. And I need to be able to say, find the antiderivative that is, what function has a derivative of 3x squared? Oops, that's a question mark. That's a terrible question mark. I got to fix it. So when I say find the antiderivative of 3x squared, I'm saying what function's derivative is 3x squared? And we already know that it's x cubed. We do want to think about the process, though. It's like, well, there's got to be some trick to it, right? So think about what we did going from x cubed to 3x squared. We multiplied by the exponent and then subtracted 1 from the exponent. So multiply by the exponent. And second, we subtract 1 from the exponent. That's how we go from a function to its derivative. So to undo this, we just perform the inverse operations in reverse order. Instead of subtracting 1 from the exponent, we're going to add 1 to the exponent. Instead of multiplying by the new exponent, we're going to divide by that exponent. That's just the inverse process. So the antiderivative of 3x squared I spelled A wrong. I should say an antiderivative of 3x squared is x cubed. We're going to do the inverse of the find derivative process. The inverse of subtract 1 from the exponent, we add 1 to the exponent. And then next, the inverse of multiply by the exponent is divide by the exponent. We're performing inverse operations in reverse order. We're performing inverse operations in reverse order, just like when we're trying to solve an equation. That would have sounded super familiar if any of you had been in my algebra class, where this is how I talk about solving equations, performing inverse operations in reverse order. But this is how we do things. We look at the process we did going forward to find the derivative of x cubed, nx to the n minus 1. That's the formula way to think about it. Process-wise, we put the exponent in front, 3. We multiply by the exponent. Then we subtract 1 from the exponent in that order. We don't subtract 1 from the exponent first, because then it would look like 2x squared. That's not the derivative. We multiply by the exponent, then we subtract 1 from the exponent. So if we want to undo this process, we invert the operations in reverse order. we add 1 to the exponent, then we divide by that exponent. You have to perform inverse operations in reverse order. If you start with bare feet, and first you put your socks on, then you put your shoes on, to get back to bare feet, first you take your shoes off, then you take your socks off, then you're back to where you started with bare feet. Can't take your socks off first, unless the socks have holes that would fit around your shoe. I mean, there's that, I guess. But if you have to dig that far for some weirdo case, then clearly you're just deliberately misunderstanding what's going on. Any questions? So here's the antiderivative process. We add 1 to the exponent, and then we divide by that exponent. So the antiderivative of 3x squared, we add 1 to the exponent, it becomes a cube, and then we divide by the cube, or by the 3. 3 divided by 3 is 1. So another example, find antiderivative of 5x to the third. So the process is to add 1 to the exponent and then divide by the exponent. So we add 1 to the exponent and divide by that exponent. 5 just gets carried along. We can check to see that we're right by doing the derivative. If this is supposed to be the antiderivative, the derivative of 5/4 x to the fourth, we multiply by the exponent. 4 times 5/4 is 5. And we subtract 1 from the exponent. X to the fourth becomes x to the third. So this is an antiderivative of 5x to the third. 5/4 x to the fourth is a function whose derivative is 5x to the third. Any questions? This is still not connected to the thing that we did yesterday or that we continued today. It's still not connected to this area idea. But we needed to grab something familiar, and classes only is barely an hour long. That something familiar is going to be derivative, but we're going to have to do it backwards. We go forwards through the class, then we go backwards through the class, and that's the phase that we're on right now. So before we were finding derivatives, now we're just doing that in reverse to find antiderivatives. The big question for today, which will make everything clear if I would just answer it, is to point out that I use the word an antiderivative and not the antiderivative. I said an antiderivative and not the antiderivative. I also said that that antiderivative is like the inverse process. But those two statements are incompatible. If it's an inverse process, how come there's an antiderivative and not the antiderivative? So let me clear that up by saying, oh, dang, look at the time. That's going to do it for today. Tomorrow, you'll have to tell me why I said an antiderivative and not the antiderivative. Let's pause the video here and talk about tomorrow.